Question 8. A. Find the mean of xt, and we know xt is equal to the interval from 0 to 2, from 0 to 2, the number of n t1 t2 of the point I in the interval t1 t2 of the length t equal to t2 minus t1 is a Poisson random variable with parameter lambda t. So it means that in this interview we have that pxt equal to k is equal to in this in 0 to 2, 0 to t, this interval, the probability of xt equal to k is equal to this one. So from what we know before that, this one, we know the discrete Poisson function is this, and is equal to 1, and we can get that the same as this one. So we just need to assume that lambda t is equal to a. So finally, this part its mean is equal to its mean is a. So we also can infer that this mean this lambda t this Poisson function's mean is equal to lambda t. It's about parameter lambda t. So it's very easy to get the first pass answer. Okay. Part B. And we know that the autocorrelation of T1 and T2 is equal to xt1, xt2. And we know that xt1 is equal to lambda t1. And this is lambda t2. So we can get that it's equal to lambda t1, lambda t2. So it's become to this is we can write it. And we know that from the question, we know that if the interval t1, t2, and the interval t3 to t4 are non-overlapping, then the random variable t1, t2, and t3, t4 are independent. So we do not know how to transfer this part, so we can just write it as lambda t1 plus lambda t2. If we can take it out and divide it into two parts, I think it's easy for us to solve this problem. So we assume that t1 is bigger than t2, so we can get that it's equal to lambda t1. Lambda t1 is also equal to x, so it's ext1 plus xt1 minus xt2 plus xt. Here is minus xt1 minus xt2. No. Here is xt2 minus xt1 and plus xt1. No, here we assume that t2 we assume that T2 is bigger than T1, and so we can rewrite theta this way. So we know this part has no overlapping with this part since in the line of time. So here is T1, there is 0, here is T1, here is T2. So from T1 to T2, there is no overlapping with this area. So we can assume that we can transfer it. This part, this is we can think is independent. So you can transfer it into this. And this ext1 the power to ext1, we can know that the E is lambda t, and so the eta is lambda t, and we can know that the variance of the persons is also lambda t. So we can get that it should be lambda t power to lambda t plus lambda t. So this is this part, and we need to find this part. What's this part? We know this is lambda t1 and this is lambda. We can transfer it to lambda t2 minus lambda t1. So it's become lambda t1 t2 plus lambda t1 and plus lambda t1 plus lambda t1. And this part we can get. So it's finally become lambda t1 t2 minus lambda t1. Also, if we assume that t2 is minus t2, so we also can get that t2 minus lambda t2. So this part is changed with relation between T2 and T1. So if T2 is smaller than T1, there is T2. If T1 is smaller than T2, there is T1. So we can rewrite it as the autocorrelation of RT1 and T2 is equal to lambda power to lambda t1 plus multiply t2 Miller function. We use lambda t1 and t2. So here we get that the autocorrelation. Okay, that's all.